How you doing, folks? Mr. D here. Welcome to our numeracy lesson number 6, heart rate and calories burned. This is part of our Running the Numbers series. So we're going to look at, some of the numeracy skills involved with figuring out your heart rate and calculating your calories burned and so forth. So our first scenario we're going to look at here is we're going to record our average heart rate, and then we're going to use this formula, which we've seen before, for using calories burned, and then to discuss how calories burned varies based on heart rate and body weight. So let's just say that I trained at 110 beats per minute, and I did it for 30 minutes, and I weighed 200 pounds. Now, if you recall, the weight in this formula that I gave you has to be in kilograms. Okay, so a lot of times when you use all these different formulas, you got to have certain units a certain way. And so I need to use the formula. I got to take my pounds, whatever my pounds are, and divide by 2.205. And that gives me the kilograms. So in this instance, I use 200. And that comes out to roughly 90.7 kilograms. Okay. And the time in this formula, this particular formula, the way it's set up, that time is in minutes. So we're going to straight put 30 minutes into that formula. Okay. So I set up my formula. So I get this whole group of parentheses, and I've got, you see, I'm going to say, 53 for the age. So it's an age, and then it's times 0.2017, that's just a constant in the formula, minus the weight, and I put in 90.7 kilograms is what I calculated, times another constant of 0.09036, plus my heart rate that I came up with was 110, times another constant of 0.6309, and then minus the constant of 55.0969. That whole thing is in parentheses. And then we multiply by our time, which in our example, we're going to say we trained for 30 minutes. And then we divide all of that by the 4.184. Okay. And so I do order of operations. I'm going to do multiplication first. I'm going to multiply those two, these two, and these two first. And so that gives me the first 53 times the 0.2017. That comes out to 10.6901. Minus the 90.7 times the 0.09036. That comes up to 8.19562. Actually, 5652. A lot of decimals on that one. And then lastly, I've got plus the 110 times the 0.6309. That comes out to 69.399. And then I've got the minus 55 number at the end. That's all still in parentheses, times the 30, divided by the 4.184. Now I do the addition and subtraction in that parentheses right here. And that number comes out to 16.796548. Then I multiply by the 30, now that I've done everything inside of the parentheses. That comes out to 503.89644. And then lastly, I'm going to divide by the 4.184, and that comes out to about 120.4 calories. Okay. And then we're just going to look at this formula a minute here and go, how does that calories burned get affected by the heart rate? Well, that number, as that number gets bigger, you get a bigger number in the top here, it's going to increase the calories burned, right? Kind of common sense. You figure if you work harder, you're going to burn more calories. And same thing with your weight, actually. If your weight increases, actually, that gets subtracted. So if you take your weight and you multiply this by your number, okay, you're going to get a smaller number up top here. Okay. So, that's we've already investigated that formula, but again, it's just talking about a scenario where you look at your training time and your heart rate. The next example, we're going to estimate calories burned using a much simpler formula, which is your metabolic rate, which is called MET, times your weight times your time in hours. So again, your weight's in kilograms. And so we're going to compare the outcomes for different exercises. So in this one, they tell us the metabolic rate, the MET for walking, is 3.5, and the metabolic rate, MET, for running is higher. Not surprisingly, it's for 8. So let's assume that we're the same weight for a good comparison. And I'm going to use, 90 kilograms as my example. And so let's look at walking. And so using that formula, it's MET, the metabolic rate for walking is 3.5. And then we multiply by the time. So let's just say we're doing it for a half hour. And then 90 for the weight. 90 kilograms. And that comes out to about 157.5 calories. And I want to compare that with running. What if I decide to run? Well, that metabolic rate we said was 8. So I've got 8 times the half hour times my 90 kilograms. And that comes out to about 360 calories. So, more than double when you run. Okay? So, it's if you want to compare and you're trying to max out or trying to optimize your calorie burning, you can use some little formulas like that. So, we've been talking about your heart rate. So, calculating heart rate, most of the time what we do is we count our pulse. You can, right behind your wristband, you can put 2 fingers there and feel your heartbeat and count for 15 seconds. And then there's 15 seconds goes 4 times into a minute. So you just multiply by 4. So let's say I count 17 beats in 15 seconds. I just go times 4 and that gives me a pulse rate of 68 beats per minute. Let's say I count 22 beats. Then I go times 4 and that gives me a pulse rate of 80 beats per minute and so forth. So that's how you do that. Okay. So next we're going to look at heart rate zones, beats per minute zone. Okay. There's what we call optimal zones for burning fat. Burning fat is usually between the range of 60 or 70% of your max heart rate. And your max heart rate it goes down with age. You start with 220 and you subtract your age. So as you subtract bigger ages, your max heart rate goes down. So let's find out my optimal training zone. I'm 53 years old. So I'm gonna go 220 minus 53, which is 167. That's my max heart rate. And so I want to find my range for training. So my lower range, I'm going to multiply by 0.60 for 60%. That'll give me my lower heart rate range. And my upper heart rate range will be 0.70. And that'll be my training zone for maxing out fat burning. So when I do 0.6 times 167, that comes out to about 100 beats per minute. And when I multiply by 0.7, that comes out to about 117 beats per minute. So my zone is 100 to 117 beats per minute. Okay. And lastly, we're going to look at, I'm going to analyze a meal from fast food and look at how long it takes to walk versus jog to burn that meal. So the meal I picked, one of the more famous fast food meals, was a Big Mac meal. And I just Googled what that calorie was, and it's about 1,120 calories. Okay? And so my formula for calories, remember, is the MET, the metabolic rate, times the weight, my weight, times the time. And what I'm trying to figure out is the time for each of these. So let's look at the walking. Okay. My walking has a metabolic rate of 3.5. And let's just assume my weight was 90 kilograms. It's not, I don't think, but we'll go with 90. And I don't know what my time is. I'm going to solve for the time. So I'm going to just put a variable t. And I want this to equal the 1,120 calories. And so when I multiply 3.5 times 90, I get 315. So I have 315 times t has to equal 1120. And so t is being multiplied by 315. So I'm going to divide both sides by 315 to cancel it out. And that comes out to about 3.56 hours of walking to burn off that one meal. Quite a bit. Let's see what happens if we ramp it up and we run. Okay, the metabolic rate for running is 8 times my weight of 90 times t. And so 8 times 90 is 720. So I have 720 t has to equal the 1120. And so this time, t is being multiplied by 720. So I'm going to divide by 720. And that gives me about 1.56 hours. A lot less, but still, that's a lot of running to burn that off, isn't it? Might make you think, if you're training, might make you think twice about eating that Big Mac meal. That's a lot of calories. So on your own, that would be a good activity for you to do, is look at your meals okay? And you can Google them. Estimate your intake of calories and just reflect on what kind of training will take to burn that energy. And so that's just another good activity for you to look at. And so this was all about heart rate and calories burned. I hope you enjoyed this lesson, and have a great day.